Hello and welcome to the Functional Skills Maths Practice Paper 1 at Level 2. I'm going to do Section A initially. This is the non-calculated paper that lasts 25 minutes and has 15 marks. What we really need from you is for you to have a go at this manually. So don't worry if you haven't done it exactly the way I'm going to show you. There are other ways of answering the questions. As long as you get them right, that's okay. So the first question is about BIDMAS. So we have brackets, indices, division and multiplication, addition and subtraction. Now, brackets comes first, so we need to do what's inside the brackets first. And this takes us to our lower rules of division and multiplication before addition and subtraction. So it becomes 7 plus 12, and that becomes 19, and we need to square it. So to do this manually, you can do it using the box method. So 10 and 9, 10 and 9, because 19 squared means 19 times 19. So 10 tens are 100, 9 tens are 90, 9 tens are 90, and 9 nines are 81. Add each of your columns, and then add the two amounts. And you end up with 361 as the solution to the problem. The next question is checking to see if you can divide a decimal by a decimal. The process for doing this is to remove the decimal place on the thing doing the dividing. So it's going to become whatever it is divided by 5. Now, if you move this side one decimal place, you need to move this side by one decimal place, so you don't have to change your answer. So 125.5 divided by 5 is exactly the same answer as 12.55 divided by 0.5. So now we do the division. So it's 125.5 divided by 5. So 5 doesn't go into 1, so carry the 1. 5 goes into 12 twice, remainder 2. 5 goes into 25 5 times, no remainder, don't forget your decimal place. And 5 goes into 5 once. So our answer is 25.1. Question 3 is asking us to round this number to 3 decimal places. So the third decimal place is the number 8. Look at the next number along to decide whether to stick with the 8 or go up to a 9. Because it's a 3, we stick with the 8. So our answer is 23.728. Question 4 is asking us to write down the coordinate of point A. So this is point A here. So on our x-axis it's 4 along, on our y-axis it's 0 up or down. Don't forget the brackets and the comma that separates your two values. So brackets 4, 0, close the brackets, gets you the mark. Question 5 is stating that AB is the base of an isosceles triangle ABC. Plot and label the point C. Now there are lots of options for C. If this is the base of the triangle between A and B, if we take the midpoint, which is 1, and go here, or here, or here, or here. Conversely, if you go here, 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 or here, any of these will draw an isosceles triangle that has the base AB, because this length will always be the same as this length. So any of these coordinates will get you the mark. So the coordinates we have that get you the mark. So any of these coordinates should get you the 1 mark to create your isosceles triangle. Now the problem you've got is for question 6, calculate the area of your triangle will depend on which one of these you chose to make the top of your triangle. So let's just say we went for this point here, and this is our isosceles triangle that we have to calculate our area? Well, the base is 1, 2, 3, 4, 5, 6 long, so it's half times 6, which is 3, times the vertical height, which is 1, 2, 3, 4. So half the base times the vertical height gives us 12, and let's just assume it's in centimeters squared for the area. So it's in centimeters squared. Now, depending on which triangle you chose will depend on the value of your height. So there are lots of answers for this area question. As long as you've multiplied 3 by the y value, you should get the marks. Question 7 is asking us to write some decimals in numerical order. The process for doing this is look at the longest decimal and say there are 3 decimal places. Make all of your other numbers 3 decimal places long so that you can now compare like with like. So 700 compared to 60, compared to 637, 670 and 6. It's asking us to start with the smallest first, so 6 is our smallest number. Our next smallest number is 60, so we write the actual number down. Our next number is 637. Then we have 670, and then finally the 700. So this is the correct order for these numbers, starting with the smallest. Question 8 is asking us to find the value of 6ab minus 12 when a is 2 and b is 5. So the best way to do this is write your algebra out in longhand. So 6 times a times b minus 12. Swap the letters for the numbers. So 6 times 2 times 5 minus 12. BIDMAS tells us to do the multiplication first, starting on the left. So 12 times 5 minus 12. 12 times 5 is 60. Take away 12 is 48. So the correct value for 1 mark is 48. Question 9 says a window, which contains the glass and the frame, has an area of 1800 centimeters squared. The area of the glass is 1710 centimeters squared. What percentage of the window is the area of the frame? So to work out the area of the frame, we can subtract it from the area of the glass. So 1800 take away 1710 is 90. So we have 90 over 1800. We can simplify this to make it 9 over 180 times 100 to turn it into a percentage. Now, what you can do is you can do the 9 times 100 first, so it becomes 900 divided by 180. These zeros cancel out, so it becomes 90 divided by 18. Let's do that calculation. 90 divided by 18. So it's testing your ability to do long division. So the way to do long division is do a little chart here on the left, doing your 18 times tables. So I know 118 is 18, and I double it to get 36. If I double it again, I get 72, so that's 4 lots of 18. And if I add another 18 to it, I get 90. So that's 5 lots. So 18 goes into 90 5 times. So our percentage is 5%. Question 10 states a loan of £387 needs to be repaid with 35% interest. Calculate the total amount of interest that will be needed to be repaid. So whenever you see a percentage amount in a non-calculator paper, we use the 10% rule. So 10% of 387 is £38.70. We need 30%, so we need 3 lots of it, so 38.7 times 3. We can do this by using our multiplication method for decimals, move the decimal point, do the maths and put the decimal point back. So I get 1161, put my decimal point back, and I get 116.1. And that looks correct. 3 lots of 38 is roughly 116. We also need to find out the 5%. So if 10% is £38.70, we need to divide that by 2. So 5% is £19.35. So we've got our 5%, we've got our 30%. So to get our 35%, we add the 2 together. And you end up with £135.45 as the total interest that needs to be repaid. Next, we need to find the surface area of this cube. So you need to remember some of the properties of the cube. So the cube has all sides the same length. So all 3 dimensions are the same. To calculate surface area, we need the area of each of the 6 sides. Now we're quite lucky because they're all the same. So one of the sides is 4 by 4 centimeters, which is 16 centimeters squared. And there are 6 sides, much like a dice, for this cube. So we need 16 times 6 to work out our total surface area. You can do this either way on your multiplication. So I'll use the traditional method where 6 6s are 36, 6 1s are 6, plus the 3 is 9. So you end up with 96 centimeters squared. So your surface area for the cube is 96, and don't forget the units are centimeters squared because we're talking about area. Question 12 is asking us to draw the plan view of this solid. Normally you would expect to have some kind of squared paper with this question in order to do this. But for now, what I will do is I will freehand these squares. So we're looking down on the shape for our plan view. And if you look down on it, you have 2 squares, one above the other, that make up this bit here. We also need 2 squares going that way to represent this L shape that we would see from above. So the plan view for the solid should look something like this. It doesn't matter which way round you do it. If you do it that way round, that is also the correct answer. Question 13 is asking us to share £60 in the ratio of 5 to 7. So the £60 is going to be shared between both of them. So it's a totals ratio question. So the total goes off to the right. Our ratio lives over here. Now, when you've got a totals question, you need to divide it by the total number of parts. So 5 plus 7 gives us 12 parts. The total amount divided by the total number of parts gives us our scale. So 60 divided by 12 gives us 5. We go back to our ratio, multiply each side by 5, and it tells us what each of the 2 ratios should receive. So it should be £25 to 35, and our check is that when we add these 2 together, we get our total amount of £60. Question 14 is asking us to calculate the total area of the shaded sections. It's telling us that the radius of the circle is 6 centimeters. So let's just draw that in so we don't make any mistakes. So the radius is 6 centimeters, and we need to use pi as 3.1. Now the way to work out this grey shaded area is to work out the area of the square first and then take away the area of the circle. So our square is 12 centimeters wide from side to side, because half the distance is the radius of the circle. So the area of the whole square, because it's a square, is 12 by 12, which is 144 centimeters squared. The area of our circle is, as you have to remember, pi r squared, where we've been told pi is 3.1. We have to multiply it by the radius, which is 6, and don't forget to square it. So the area of our circle is 3.1 times 36. So we're multiplying a decimal by a whole number. All we need to do is move the decimal place to one side, and the problem becomes 31 times 36. So let's do that using our box method. So 3 3s are 9 with 2 zeros. 6 3s are 18 with 1 0. 3 1s are 3 with a 0. And we've got 6. Add each of the columns up. And then add the two numbers together. Don't forget to put your decimal place back, because we didn't have 31, we had 3.1. So one place back to the left gives us the area of the circle as 111.6 centimeters squared. So our shaded area is the area of the square, take away the area of our circle. Do the maths for this. Don't forget your decimal point. And you end up with 32.4 centimeters squared as the area of the grey shaded areas. So the area of the square, take away the area of the circle. Question 15 is asking us to subtract 4 1/3 from 2 3/7. The best way to do this is to turn it into an improper fraction. So 3 times 4 is 12, plus the 1 we've already got is 13 over 3. This mixed number is the improper fraction 13 over 3. This improper fraction is 7 times 2, which is 14, plus the 3 we've already got, which is 17, and it still needs to be divided by 7. So our problem becomes 13 over 3 take away 17 over 7. Now we can't do this because the denominators are different, so we need a common denominator, a number 3 and 7 both go into. So 3 times 7 gives us 21 as a common denominator. To get from the 3 to the 21, we multiplied it by 7, so we need to multiply 13 by 7, which is 91 over 21. To get from the 7 to the 21, we multiplied it by 3, so 17 times 3 is 51. Now we can do the maths. 91 take away 51 is 40, and it's all over 21. They want the answer as a mixed number, so 21 goes into 40 one whole time, remainder 19, and the 19 still needs to be divided by 21. 19's a prime number and it doesn't divide into 21, therefore we can leave this part of the fraction as it is. So our answer is one whole number and 19 21s. And that is the end of section A for paper 1, level 2. Okay, now we're going to look at section B, where we are allowed to use our calculator. This part of the exam lasts 1 hour 20 minutes and there are 45 marks available. Other than simple calculations, I will show you the calculations and the buttons to press on our little calculator here. So if it's a basic calculation, I won't show you if it's addition, subtraction, multiplication or division. But if it's a fraction of amount, a percentage, anything slightly more difficult, I will call up this calculator display and show you how to press the buttons to get the answer. Okay, question 1 is all about smartphones. Screen displays are made up of small dots called pixels. A popular size of smartphone screen is 1080 pixels by 1920 pixels. Simplify the ratio 1080 to 1920. Now there's a quick and easy way to do this. A lot of you would look at this and start simplifying it by dividing it by 10, then divide it by 2, and then look at other numbers that you can divide it. But actually, there's a lot quicker way to get the calculator to simplify it for you. Create a fraction between your two numbers, and the calculator, just press equals, so create the fraction, press equals, and the calculator will tell you the smallest number that goes into both of these. So let me show you that. Create the fraction 1080, down rocker switch to get your 1920, press equals, and it tells you that it's 9 to 16. So your ratio simplified is 9 to 16. So the calculator has done all of the hard work for us by simplifying a fraction and giving us the two numbers that these simplify to as low as possible. Part B. Kai reads that in a survey of 225 people, 198 people owned a smartphone. What fraction of these people owned a smartphone? So we're creating a fraction of 198 over 225. Now, exactly as I showed you on the last part of the question, use your calculator to simplify fractions. Call up your calculator and then put in the fraction. 198 as your numerator, rocker switch down, 225 as your denominator, and just press equals. It will simplify it for you. So it's 22 over 25. So the fraction of people that own a smartphone is 22 over 25. Part C states that which of these rectangles have side lengths in the ratio of 1080 to 1920. And what you need to do, the trick to this, is go back to part A and use the simplified ratio of 9 to 16. So you're looking for ratios of 9 to 16. It's far more easy to manage than this 1080 to 1920. Let me show you what I mean. So for shape A, just count the squares. There are 5, 10, 15, 16 squares along, and then there are 5, 10 squares down. So we have a ratio of 16 to 10 for shape A. And this matches up, but this doesn't. So shape A is not in that ratio. Let's have a look at shape B. We have 5, 10, 15, 16 squares down, and 5, 6, 7, 8, 9 squares across. So our ratio is 16 to 9, which matches up to our original. So shape B is in the ratio of 1080 to 1920. Do the same for shape C. So we're looking for a ratio of 9 to 16. Let's count the squares. 5, 10, 15, 16, 17, 18, 19 squares down, 5, 10, 11 squares across. So we have a ratio of 19 to 11. So whatever your scale is to get from here to here, it needs to be the same scale to get from there to there. So divide 11 by 9 and it will give us our scale here. And it's 1.2 recurring. Do the same over here. Divide 19 by 16 to get the scale here that we're multiplying by, and we get 1.18. So these scales are different. So C cannot be in the ratio of 1080 to 1920. Let's do the same for rectangle D. We're looking for a ratio of 9 to 16. Let's count the squares. 5, 10, 15, 20, 25, 32. So that side is 32. 5, 10, 15, 16, 17, 18. So it has a ratio of 18 to 32. You can see you've multiplied by 2 on this side and the same on this side. So D is in the correct ratio. So our working out is above, looking at our ratio of 9 to 16, and we know that B and D are in the ratio that we're looking for of 1080 to 1920. Question 2. Jane reads that some companies define screen size as the length of the diagonal of the screen in inches. The shaded rectangle is a scale drawing of a smartphone screen. Use the scale drawing to find out the length of its diagonal in millimeters. Now, when I looked at this question, I assumed that this was 2 centimeters, but it isn't. When you get your ruler out, you find that 2 centimeters actually is that amount. So the thing you need to be aware of is that this drawing is not to scale. So you can't just put your ruler on and start reading what your ruler says. You're going to have to use this scale here, which is 5 squares is 2 centimeters, and just take this diagonal value, which we'll measure on your ruler, and you get 6 centimeters. When you put 6 centimeters starting here and measure it out, it actually takes up 18 squares. So we take this measurement here and turn it into squares by laying it flat. So you take your 18 squares that you've measured as your diagonal, not the centimeters, and put it under the square side of your ratio. How did you get from 5 to 18? So divide 18 by 5 and you get 3.6. Do this on your calculator, don't do it manually. And then that gives you your scale that you've multiplied your 5 by to get your 18. Do the same on the other side and you end up with 7.2 centimeters as the diagonal length. Don't forget, the question is asking for that diagonal length in millimeters. So 7.2 centimeters multiplied by 10 gives you 72 millimeters. So on the answer line down below, write 72 millimeters as your answer. The second part of the question says find the screen size in inches and give your answer correct to 1 decimal place. And it gives us a strap line. So whenever you see something equals something, it is the numbers you need for a strap line. So 1 inch is 25.4 millimeters. We don't have 25.4 millimeters, we have 72 millimeters. So to get your scale, divide your 72 by 25.4 and it will give you that scale. Now the number on the calculator is very long. Because we want it to correct to 1 decimal place, let's just put 2 decimal places down and round it from here. So rounded, it is 2.8. So let's multiply by 2.8 and then our answer is accurate to 1 decimal place. So we get 2.8 inches as our answer. Part B of this question says that Jane says that the screen size is directly proportional to the screen area. She collects this information. What that means is this relationship here should be exactly the same as any of these other relationships. And as I look across the line, another easy one to check would be these, because it's double. 3.5 doubled is 7. So my relationship between my screen size, which is 3.5 inches, and my screen area, which is 5.23. If I use this as my relationship, then if I multiply this by 2, my screen size is 7 inches. If I multiply one side by 2 to be directly proportional, I need to multiply the other side by 2, then the 7-inch screen should have an area of 10.46. And it doesn't. It's 20.94. So is she correct? No, she is not. Because if it was directly proportional, this would be 10.46. Question 3 is about choosing a phone. Kai wants the new GS2 smartphone, and there are two options. Option 1 shows 24 months at £28 per month and a £25 one-off payment. Option 2 is £10 a month for a SIM card and just buy the phone for £375. Kai wants to know which is the cheaper of the two options for 24 months. So we have to tick the cheapest option in our answer box further down. So let's look at the two options. Let's look at option 1 first and make it nice and clear for our examiner. Option 1 is 24 months at £28 per month. So do this on your calculator, which is £672. We then need to add the one-off payment of £25. So again, no chances, do it on your calculator. So the answer for option 1 is £697. Let's look at option 2 then. We've got 24 months at £10 a month, which is £240. We then have to have a one-off purchase price of our phone, which gives us 240 plus the 375. No chances, do it on your calculator, and the option 2 is £615. So the option he should go for is option 2. So tick the option 2 box. Part B states that the GS2 smartphone in option 2 is reduced from 375 to 335. Calculate the percentage reduction in price and give your answer to the nearest whole number. So this is a percentage change question, and you need to remember the formula for doing it. It's the difference in price divided by the original times 100. So let's put the numbers in for this. The difference in price is 375 minus 335. Do it on your calculator so you don't make any mistakes. That's £40 difference. So the difference is 40. The original price is 375, and then we need to multiply that by 100 to get our percentage. Let's do that on a calculator, exactly as it looks. So we've got a fraction, which is 40 as the numerator and 375 as the denominator. Move the rocker to the right and then multiply it by 100. Press equals. It gives you an improper fraction. Press SD to get your decimal, and you end up with 10.6 with a little dot over it. Don't forget the little dot. So our answer on our calculator was 10.6 with a little dot. And for those of you who remember your recurring, this is what it means. It goes on forever. Give your answer to the nearest whole number. So the whole number is here. Look at the next bit to decide whether to stick on 0 or go up to 1. Because it's higher than 5, we change this 0 to a 1. So our final answer rounded is 11%. Question 4. Kai decides to buy a GS3X mobile phone and he needs a loan of £400. He's going to pay this back after 3 months, which is 90 days, and we need to investigate these 3 loans. It's asking us which loan is the most expensive. So let's do the working out here by the loans. Loan A says there are 3 equal monthly payments based on the table below. So the amount we're looking at is £400 and the monthly repayment is £200. So 3 months at £200 per month means he would repay £600 for loan A. Loan B says at the end of 3 months, pay back the £400 plus interest of 75 pence each day for each £100. So 75 pence times 4, because we're borrowing £400, means every day you're repaying £3. We need this loan for 90 days, so 3 lots of £90 is £270 interest. Add the £400 original and your total for loan B is £670. Now let's look at loan C. At the end of the 3 months, pay back the £400 plus 10% per month compound interest. So we need to look at the 3 months. So let's look at the first month. At the start of the first month we had £400 and we need to add 10%. Well, 10% of 400 is £40. So at the end of month 1 we owe £440. Month 2 then, we need to find 10% of 440, which is £44. So at the end of month 2 we have our £440 plus the 44 gives us £484. For month 3 we need to find 10% of £484, which is £48.40. So we have £484 and we need to add £48.40, which gives us our total for loan C as £532.40. So loan C is cheaper by quite a bit. Loan A is £600, loan B is £670, and loan C is £532.40. So it's asking us for the most expensive loan. So we've done all the working out above. So loan B is the most expensive loan, and the cost of that loan, if we remember, is £670. Question 5. Jane wants to run a competition to get more customers into the shop, and she's got this idea to fill a large upturned cone with smartphones. Customers will need to guess the value of the smartphones in the cone, and the nearest guess wins. The cone will have a height of 0.5 meter and a radius of 1.5 meters. So let's make sure we don't make any mistakes. The radius is 1.5 meters and our height is 0.5 of a meter. Calculate the volume of the cone. The volume of a cone is 1/3 pi r squared times h. Now, we're in the calculator exam, so we can break this down in longhand to what the various numbers are. We have 1/3. They haven't told us what pi is, so we're going to use 3.14. We're then going to multiply it by the radius squared. The radius is 1.5 meters, and we've squared it. And then we need to multiply it by the height, and the height is 0.5. So you can put this into your calculator exactly as it looks. We know the fraction button there is 1/3. Move the rocker to the right and then multiply it by our value for pi, which is 3.14. Then multiply it by the radius 1.5, but don't forget to square it. Then multiply that by 0.5. Press equals, because the calculator's going to do all the hard work, and press the SD button to turn our improper fraction into a decimal. And you end up with 1.1775 meters cubed, because it's volume. So it's 1.1775 meters cubed. Okay, the next part of the question says that Jane wants to calculate an estimate for the value of smartphones, and she makes some assumptions about the smartphone. She says it's a cuboid of 15 centimeters by 7 by 1. They will completely fill the cone to the top with no empty spaces, and a smartphone is worth around £200. Use your answer for part A1 and James' assumptions to calculate an estimate for the value of the smartphones in the cone. Give your answer to a sensible accuracy. So there are several things we need to remember. That we've already worked out the volume of the cone, which is 1.1775 meters cubed. Now we're working in meters cubed, so these values here need to be changed into meters so that when we work out the volume of the phone, it's in meters, so we can divide the big volume by the little volume. So to go from centimeters to meters, we're going from small to big, so we divide centi by 100. So 15 divided by 100, do it on your calculator, is 0.15. 7 divided by 100 is 0.07 meters. And then finally 1 centimeter divided by 100 is 0.01 meter. So the volume of the phone is 0.15 times 0.07 times 0.01. And this is a very small number. And this is 0.0000105. Now some calculators show 1.05 times 10 to the minus 4. If your calculator is showing this, you need to change the format of your display. So ask your teacher. Okay, so now we've got our volume in meters of our mobile phone. We need to divide the volume of our cone, which is in meters cubed, by the volume of our mobile phone, and this will tell us how many mobile phones fit into the cone. And the number the calculator shows is 11214.28. And there are some more decimal places, but it is telling us to be sensible. So let's choose a sensible number, and that is 11,214 phones, and each phone costs £200. And you end up with £2,242,800 as the amount. It asks us to estimate, so we can estimate the price as 2.2 million. So our estimate would be £2.2 million worth of phones in the cone. The final part of the question says that Jane's next competition is a speed texting contest. The world record texting speed is 1.47 words per second. The winner in Jane's contest is 25 words in 35.54 seconds. Jane says that this is less than half the speed of the world record. So the world record, we have a relationship between words and seconds, and it's 1.47 words per second. In her competition, she has somebody who did 25 words in 35.54 seconds. So to compare like with like, we need to force this to be the number one. so we divide it by itself. It's a unitary method. And if we divide this side by 35.54, we need to divide the other side by 35.54. So 25 divided by 35.54 equals 0.703. So 0.703 words per second was the speed of the person that they were competing with. So to show that this is less than half of the speed of the world champion, we need to take our winner's speed of 0.703 words per second and double it. And you get 1.406 words per second. And this is still less than our world record. So Jane is correct. It is less than half the speed. This concludes the paper for level 2, and this is the end of practice paper 1. If there's anything you're confused with in the paper that you don't understand, then please don't hesitate to ask your tutor. Thank you for watching the video. I hope it's been of some use.